Hey guys, this is Mr. C, and in this video we're going to be talking about exponential growth and decay. So we're going to start out with what exponential growth looks like, and we see our exponential function here. We know it's exponential because it has a variable in the exponent. The y would be the output. That x right there would be the input, or the independent variable. You have the initial value and 1 plus r. R is the rate of growth, and we need to use that as a decimal. We add that to 1, which is the whole, and we're going to get growth out of that. And again, A is just the initial value. So let's say you open up a savings account with $500. Well, the A would be the $500 in that case. Decay is the opposite. Decay is going to represent situations where things are declining exponentially. So it looks just like growth, except you have a minus right there. And so your rate again is going to be a decimal. And then your A is your initial value. Again, you got your exponent here, which is your independent variable. Got your dependent variable here. And AR is still the rate of decay, and A is still the initial value. Then I've got this little slide here. If you have an exponential function given to you like this, with A, B to the X, we know it's going to be growth if this B, or the base, is greater than 1. And we know it's going to be decay if the base is between 0 and 1. So this kind of just tells you how to tell if a function, exponential function, is going to be growth or decay. And then finally, we have compound interest. Compound interest is also exponential, but you're going to use this formula here if you're talking about a compounding period that is not yearly. So if we're talking about monthly, weekly, daily, and so let's say monthly. It says X is the number of years right there. A is initial value right there. R is the rate of growth as a decimal right there. Then you have this N, and N is the number of compounding periods. And so if we say monthly, that would be 12 periods per year, right? So we're going to have to plug a 12 in there and a 12 in there. And then when we calculate this in the calculator, we'll just kind of have to be careful of how we put this into the calculator. All right, so that's compound interest. And so now we are going to look at some common problems. And we've got our TI30 calculator here, so that's going to help us out. First problem says, the value of a new truck depreciates by 6% each year. If the truck was purchased for $25,000, how much will the truck be worth in 10 years? First thing that catches my eye is this word depreciates, and that's going to be decay, because things that depreciate are going to go down. And so it says 6% each year, so there's our rate. And then we have our initial amount, 25,000, and then we have 10, and that's going to be our X, or our independent variable. So what we're looking for is 25,000 times, parentheses, 1 minus, because it's decay, 6% would be 0.06, and we're going to raise that to the number of years, which is 10. All right, so now we're going to put that in our calculator. And so if we have a TI30, then we're going to have to do this first in parentheses. 1 minus 0.06 equals 0.94. We got to raise that to the 10th power. Y to the X, 10 equals, and we get this big decimal. Then we're going to multiply by 25,000, and we get 13465.37785. Now money is going to round to the nearest cent. So 0.377 would round to 0.38. And that's how much the truck's going to be worth in 10 years. That's it. All right, let's look at our next one. Okay, next problem. Aaron opened a savings account with an initial deposit of $500. If the savings account earns interest at an annual rate of 1.5% and no additional money is deposited or withdrawn, how much money will be in the account after 5 years? All right, so we'll take a look. Looks like we're starting with $500, 1, and then it's going to be plus, right? Because when you have a savings account, you're going to have money going in, and it's going to be growth, and it's not going to be going out, which would be decay. So plus 1.5% would be 0.015 raised to the 5 years, 5. All right, so let's calculate that. 1 plus 0.015 equals, raised to the 5th power equals, times 500 equals 538.642, so 0.64 would be our answer. Is that answer reasonable? Yes. So after 5 years, this person only made $38.64. So is it worth it to have your money in there for 5 years? Well, I mean, maybe, maybe not. It's going to be up to you to make that decision when you're a consumer. So at least you can calculate it beforehand. All right. Next one. The value of a real estate property depreciates by 4.7% each year. If the property was initially valued at $250,000, how much will the property be worth in 3 years? Okay, so we've got 250,000, which is a lot of money. Okay, we are talking about depreciation. So 1 minus 4.7%, 0.047 is a decimal. And then 3 years, 3 goes right there. All right, 1 minus 0.047 equals, we're going to raise that to the third power, equals, and then multiply by 250,000 equals, okay, 216,380.794 would just be 79 cents. And it looks like $216,000. So how much money did they lose in 3 years if they kept it like that? 250,000 minus 216,380.79 equals $33,619.21. That looks like a lot of money to lose over 3 years. Probably would be selling that property. All right, let's take a look at our next one. Okay, this one says the value of a painting increases at an annual rate of 7.8%. If the painting is currently valued at $75,000, how much will the painting be worth in 15 years? This is going to be quite a bit because actually that's a pretty big percentage. So 75,000 times 1, okay, increases plus growth, 0.078. That's 7.8% to the 15th power. All right, let's calculate. 1 plus 0.078 equals, raise that to the 15th power, and then we're going to, let me do that one more time. Let's see, 1 plus 0.078, okay, and raise that to the 15th power. Yep, that's it. Times 75,000, and it looks like we have 2,3,1,388.98, and that would be a lot of money in 15 years, starting with just 75,000. But look at your rate. Your rate's actually pretty big. It's almost 10%. So that makes sense that it would do that over 15 years. All right. Okay, our next one, a biologist approximated the number of fish in a lake to be 575. If the population of fish is increasing at a rate of 1.9% per year, we do see increasing, how many fish will be in the lake in 6 years? All right, so we're starting with 575, 1 plus 1.9%, 0.019. Okay, we're going to raise that to the 6th power because it says 6 years. And now we calculate 1 plus 0.019. Okay, so we're going to raise that to the 6th power. And then we're going to multiply by 575. And we get 643.7436, blah, blah, blah. All right, we're talking about fish. Fish only come in whole numbers. They're integers, positive integers. So probably we're going to take the 643 and just chop off the decimal. Most of the time, that's what you want to do. Even though that 7 would round that 3 up to a 4, I usually just chop the decimal off, and most people are going to be okay with that. So 643 is the answer I'm getting. All right, let's take a look at this one. Cami opened a savings account with an initial deposit of $1,500. The interest rate is 2.2% and is compounded quarterly How much money will be in the account in 12 years if no extra money is deposited or withdrawn from the account? All right, so now we have compound interest. So we have $1,500, okay, and we have 1 plus our rate, but now we have that other formula, right? The rate is 0.022 divided by n, which is the number of compounding periods. So quarterly would be 4 times per year. Okay, we're going to raise that to the n times x. So n is 4, and then we're talking about 12 years. All right, so we just have to be a little careful when we do this. So in my calculator here, I'm going to start out with 0.022 divided by 4. Okay, I'm going to add 1 to that. I'm now going to raise that to 12 times 4 is 48. Don't do 4 and then 12. Multiply them first. I'm going to take that and multiply that by the 1,500 on the outside, and I get 1951.779 would be 7. Bumps that 7 up to an 8, that second one. So it looks like 1951.78 looks good. In 12 years, that's a reasonable answer. All right, let's take a look at this one. Kevin purchased a truck for $20,000. The value of the truck depreciates at a rate of 6.5% during the first 5 years, then at 4.5% each year thereafter. How much will the truck be worth in 8 years? Okay, so this is a two-part problem. First thing we need to do is figure out how much the truck is going to be worth after the first 5 years. So we do 20,000. Okay, 1 minus, because it's depreciating, 0.065, 6.5%, and we're going to do that for the first 5 years. All right, for the first 5 years, we've got 1 minus 0.065 and equals, okay, now raise that to the 5th power, and now we'll multiply by 20,000, and we get about 14291.83686. Now 83686. That's going to feed into the next problem. I'm going to keep every one of those digits right there to make it more accurate. So now I've used up 5 of the years. I want to know 8 years. So I've got 3 more years to go. 3. So now I'm going to take this number, this one right here. I'm going to now feed it into the second problem, 14291.83686 times 1, and now 4.5%. 1 minus 0.045, and now I need 3 more years. All right, so here we go. Okay, so 1 minus 0.045 equals, raise that to the 3rd power, and now we're going to multiply by 14291.83686 equals, and I get 12447.959 would really be 0.96. And so it's looking like after 8 years, 12447.96 is going to be the value of the truck. So here's the first 5 years, then we need another 3 to make a total of 8, right? So we just have to be careful with that and split it up into the 2 problems. Very common on EOCs, that one. All right, let's take a look here. Lisa opened a savings account with $1,000 that pays 1.8% interest compounded monthly. Kelly opened a savings account with $1,000 that pays 1.6% interest compounded daily. Neither person deposits or withdraws money from their account. After 5 years, who will have more money in their account and how much more money? All right, so let's move that up a little bit. Okay, so here we go. We got Lisa. Okay, so let's calculate Lisa. We got 1,000. So I got to write kind of small now. Okay, we do have compound interest. So 1 plus her rate is 0.018. and it's compounded monthly, so 12. And it says after 5 years, so now I need 5 times 12. Okay, so let's calculate her. So let's take our calculator, and we're gonna start with that, 0.018 divided by 12 equals, plus 1 equals, we're going to raise that to the 12 times 5 is 60 equals, and then times 1,000. And we get 1094.10. So Lisa's going to have $1,094.10. Now let's talk about the other person. Let's see, Kelly, yeah. So Kelly, over here, okay, Kelly's got $1,000. Okay, 1 plus, her rate is 1.6, so 0.016. And she's gonna do daily, so that's 365. Okay, so now that's gonna be 5 times 365. You would think that Kelly's gonna get a lot more money because that 365 right there and that 365 are huge. But remember, that's denominator is gonna take this down while this one brings it up, and there's gonna be a conflict between these. And they're both gonna be struggling as how they win. You'll learn more about this in Algebra 2 when they discuss the number E. But these two guys are gonna fight it out. So let's see how much. Let's see, times, okay. So let's see how much money she's gonna get. We'll do that over here. So we've got 0.016 divided by 365. And look, that's a really small number, plus 1. But we're gonna raise that now to 365 times 5, which is 1825, a huge number. And really our decimal isn't that big. So we're gonna multiply that by 1,000 on the outside. And I did not do that correctly, so let me do that one more time. 0.016 divided by 365 equals, I do this all the time, plus 1 equals, raised to the 1825 equals, and now we're going to multiply, I can't remember even what number I pressed, but times 1,000. Okay, I don't know, maybe I did it right. So it looks like she's gonna have 1083.2, and then that 8's gonna round up to a 9. 1083.29. So Kelly is not gonna have as much money as Lisa, even though her compounding is gonna be many, many more times than Lisa's. However, Lisa's rate is higher, a little bit higher than this one, and that's what pulls this one up past this one. So it does say how much more money, and so now all we have to do to answer that part is just take 1094.10 minus 1083.29, and it looks like $10.81. So Lisa is going to have more by $10.81. And then that's it. That answers both parts of the question. So Lisa has more, $10.81 more. All right, now move on to the next one. Jackson opened a certificate of deposit with an account with $2,000. The account pays 2.5% interest compounded quarterly. How much money will be in the account? Will the account earn in interest after 15 years? All right, so this is kind of a tricky problem. So let's see how we handle this one. So we've got $2,000. Okay, 1 plus, and then we're gonna have 2.5%, 0.025, and we're compounding quarterly, so 4. We're gonna do 15 years, so 4 times 15, and then we're gonna calculate that guy right there. So we're gonna have, let's see, 0.025 divided by 4 equals, plus 1 equals, we're going to raise that to the 15 times 4 is 60. Okay, there's our decimal, times 2,000. And we get 2906.588, so that'd be 0.59. Okay, so then the question says how much, it really says how much money will the account earn in interest after 15 years. This is just how much is going to be in there. To find out how much is going to earn in interest, you have to subtract the initial amount from the new amount, and the answer to this problem is really technically $906.59 in interest, which is quite a bit because you're talking about 15 years, compounded quarterly, and that interest rate isn't too bad, 2.5%. And then they get $906.59 in 15 years. That's if you want to leave your money in there for 15 years. So, okay, let's take a look at this one. The population of a certain city is 340,000 people. A sociologist estimates that the population will grow at a rate of 1.4% each year for the next 20 years. What will the population of the city be in 12 years? All right, so we're starting out with 340,000 people. Okay, we do have growth because it says grow, right? Plus, and we're talking about 1.4% each year, so it's not going to be compound. So 0.014. Okay, and we're going to raise that to the, what will the population be in 12 years? Raise that to the 12th power. And then we're going to calculate this guy. So 1 plus 0.014. Okay, raise that to the 12th power. And then multiply by 340,000 equals, all right, this is people. So I need to chop it off here. 401,730 people. And so I don't want that decimal part because you're not going to have decimal parts of people. You need to have a whole number. So this answer right there would be the one that I would write. All right. Now let's talk about some growth and decay here. It says determine if the equation below represents exponential growth, exponential decay, or neither. Here we're only going to look at the base here because the base is what determines it, remember? So 1 minus 0.02 would be 0.98. Well, that's between 0 and 1. So this one is going to be, because of this, decay. All right. What about this one? Determine if it represents growth, decay, or neither. 1 plus 0.15 is definitely going to be bigger than 1. So this, all of that for that base is going to be growth. Okay, here we have a base, and we don't even look at this really. 1.35 is bigger than 1, so that right there determines growth. All right, here we have 0.85, that's between 0 and 1, and so that's going to be decay. Okay, this one right here, 5/3. The initial value is 1, so 5/3 is bigger than 1, so that's going to be growth. No problem there. Here we have 1.00. Is that going to be growth, decay, or neither? Well, there's a reason why we don't want our base to be 1, because 1 to any power here is going to still be 1. And so this is actually going to be a constant function of 5 all the way through. So this one, neither. So this right here, having a base of 1, is not really a good thing when we're talking about exponential functions. So we don't want to do that. All right, here, again, I'm not worried about the 6/5, just the 4/5. That is definitely between 0 and 1 because it's a little bit smaller than 5/5, which is 1. And so that's going to be decay. All right, let's talk about this one. Okay, again, I'm not worried about the initial value. 0.998 is a little less than 1. So that's going to be decay. Okay, this one, again, not worried about that. 99/100 is a little bit less than 1, and so that's going to be decay. And then our last one, Not worried about this. 1.05 is a little bit bigger than 1, and that's going to be growth. And there you go. So hopefully this helps. Remember to like and share and subscribe to my channel if you're not already. And we will see you guys later. Bye.